response to a tissue injury, such as a skin wound, an inflammatory response is mounted to protect us against exogenous pathogens and to help clear up dead tissue and debris. But this inflammation needs to be resolved in order for tissue repair to commence. So we've been trying to understand how resolution of inflammation interfaces with tissue repair. And we've found that a group of mediators called specialized pro-resolving mediators, or SPM, are generated during tissue injury, and then when added back, they can actually help to resolve inflammation, but directly promote tissue repair. So they do this in part by reprogramming macrophages, which are immune cells that are important in tissue repair and regeneration, but they also have stimulatory roles on non-immune cells as well to directly promote tissue repair. So understanding how resolution of inflammation leads to tissue repair is important because several chronic diseases, such as diabetes, for example, are associated with delayed wound healing and chronic inflammation. So if we can find new ways of stimulating resolution, this could lead to new therapeutics. A lot of the traditional anti-inflammatory therapeutics, in contrast, actually perturb repair. So this is a real opportunity, I think, to develop new therapeutic directions. Tissue vascularization is an important component of the wound repair program, and we found that several of the SPM can stimulate tissue revascularization in the context of tissue injury or ischemia. Ischemia is something that commonly occurs in many cardiovascular diseases, and in collaboration with a vascular surgeon at UCSF, we found that local delivery of SPM can resolve inflammation and reverse adverse vascular remodeling as well. So this may be an additional approach to improving recovery following vascular surgery procedures. So far, all that's in preclinical animal models of several different contexts, and the goal is to further pursue that in human clinical trials. So many of the models that are used are similar to the pathology in humans, but ultimately we need to test it in humans to be sure that would be effective. Obesity is associated with expansion of a type of adipose tissue called white adipose tissue, and this leads to chronic inflammation and perturbs systemic metabolism. So another type of adipose tissue is called brown adipose tissue, and in an exciting recent collaboration with a group at Joslin Diabetes Center, we found that activation of brown adipose tissue can resolve inflammation and obesity and thereby improve systemic metabolism. And this is related in part to the production of Maresin 2 from brown adipose tissue. And when we add Maresin 2 back, we were able to mimic the effects of brown adipose tissue in resolving inflammation. So obesity is associated with chronic unresolved inflammation and deficits in SPM production. So definitely there's been a lot of preclinical studies showing that if you can restore those deficits, you can resolve inflammation, improve systemic metabolism, and also complications of obesity, such as delayed wound healing. It's certainly possible, but we haven't been involved in any studies where they have done that directly.